Today we're going to discuss about parallel lines and transversals. Transversal is a line that intersects two or more coplanar lines in distinct points, meaning in different points. As an example, line 1, line 2, and line 3 are intersecting in this manner. Line 1 is a transversal to line 2 and line 3 at points P and R. It's because line 1 is intersecting them in two different points. However, if we take a look at line 2 also serves as a transversal to lines 1 and line 3 because line 2 intersects lines 1 and 3 in two different points, R and Q. Also, line 3 can also be called a transversal because it intersects line 1 and 2 at points P and Q. As an example of not transversal, this is how it looks like. Take a look at this example. We will see that lines 1 and 2 are being intersected by line 3, but though there are two of them, the intersection point is only one. Therefore, line 3 is not a transversal. The same with line 1 and line 2, they cannot be transversal. Now let's talk about parallel lines and the angles that they form when they are cut by a transversal. The first type of angles are the corresponding angles. Corresponding angles are defined as a pair of angles that lie on the same side of the transversal and on the same side of the other two lines. An example is given to you. In this particular case, these two lines are parallel given the symbol. So once again, the symbol right here indicates that your lines are parallel and they are cut by a transversal. If your lines are parallel and they are cut by a transversal, the corresponding angles are said to be congruent. Likewise, the converse is also true. If the corresponding angles are congruent, then the lines are parallel. The next type of angles are the alternate interior angles. The alternate interior angles are a pair of non-adjacent angles that lie on the opposite sides of the transversal and between the other two lines. An example is given here for you. So, given these two lines that are parallel and cut by a transversal T, these two are called alternate interior angles, as well as this one. We say that if the lines are parallel and they are cut by a transversal, the alternate interior angles are going to be congruent. The converse is also true, that if the alternate interior angles are congruent, then you can conclude that your lines must be parallel. Now let's have the third pair of angles, which are the alternate exterior angles. Alternate exterior angles are defined as a pair of angles that lie on the opposite sides of the transversal and outside the other two lines. An example is given here. So again, these two lines are parallel and this is the transversal. These two are the alternate exterior angles. That's one pair of them, and on here is another pair of alternate exterior angles. We said that if the two lines are parallel and cut by a transversal, the alternate exterior angles are going to be congruent. The converse also works, that if the alternate exterior angles are congruent, you can conclude that the lines are parallel. Number 4 types of angle pairs is the interior angles on the same side of the transversal. Unlike the alternate interior or exterior angles, these two types of angles are going to be on the same side of the transversal. Interior angles on the same side of the transversal are defined as a pair of angles that lie on the same side of the transversal and in between the two lines. So, given again that these two lines are parallel and they are cut by a transversal, these are your interior angles on the same side of the transversal. And in this case, we have this as your first pair and this is your next pair. Once again, your two lines are given to be parallel and they are cut by a transversal. We say that if two lines are parallel and they are cut by a transversal, the interior angles on the same side of the transversal are going to be supplementary, meaning that their sum is going to be 180 degrees. Therefore, just as an example, if this is 60 degrees, you can conclude that this must be 120 degrees because their sum must be 180 degrees. Another example, if this is 110 degrees, so this must be 70 degrees. So that 70 plus 110 sums up to 180, making them become supplementary. In the same way that if the interior angles on the same side of the transversal are supplementary, you can conclude that your lines that have been cut by the transversal are parallel. The final type of angle pairs are the exterior angles on the same side of the transversal. Exterior angles on the same side of the transversal are a pair of angles that lie on the same side of the transversal but outside of the two lines. These are your examples. Again, these two lines are given to be parallel. This is your transversal, and whenever two parallel lines are cut by a transversal, these right here are your exterior angles on the same side of the transversal. So that's one pair. These are also another pair of exterior angles on the same side of your transversal. Now we said that if the lines are parallel and they are cut by a transversal, we say that their exterior angles on the same side of the transversal are going to be supplementary. So once again, let's say this is 80 degrees, then this should be 100 degrees. If this is, let's say, 120 degrees, then this should be 60 degrees. Why? Because their sum must total to 180 degrees, which will make them supplementary. The converse of this conditional statement is also true, which is, if the exterior angles on the same side of the transversal are supplementary, you can conclude that the lines that have been cut by a transversal are parallel lines.